NCM Learning Center.
Good morning friends. In this video, we are going to discuss about the multivibrator concepts using transistors. First, we will discuss how to solve this problem if the question is asked in astable multivibrators, then monostable multivibrator. Third, we will discuss the operations of astable, monostable and bistable multivibrators. Finally, we will discuss the derivation of time period and frequency. So we know that the multivibrators can be designed by using triple by timer IC. Already we discussed in the previous video, we discussed about the triple by timer IC concepts, how to design the multivibrator using triple by timer. Then we discussed how to solve the problems from the triple timer IC. And also we can design a multivibrator using transistor, resistor, capacitor command only. Already we discussed the what is astable, monostable and bistable multivibrators. If you want to know about the basics of astable, monostable and bistable multivibrator, just refer the previous video, triple by timer IC concept video. That video link is attached in the description box of the video. The triple by timer IC concepts and transistor concepts both are different, formulas are different. So when you are going to write the examinations, if the problem is given in the multivibrators, then we have to check whether the triple timer IC is given or not. If the triple timer IC is given, we have to use this formula. If the triple timer IC is not given, we have to use this second approach formula. Now I will list the questions. If you can able to solve these questions, no need to watch the videos further. If you are not able to solve this question, just listen this video carefully. The first question is asked in TRB 2017 EC department examination. The same question is asked in TRB 2021 examinations also. The second question is asked in TRB 2017 examination. Just try to solve these questions. Triple timer IC is given. Use this formula. For astable multivibrators, T on time is 0.6932 into R1 plus R2 into C1. For time period, of time period is equal to 0.6932 R2 into C1. This is a formula for astable multivibrator using triple timer IC. If the triple timer IC is not given and astable multivibrator is given, use this formula. T1 is on durations 0.6932 R1 C1, of durations T2 is equal to 0.6932 R2 C2. If monostable multivibrator is given and triple timer IC is given, use this formula. On period is 1.1 RC, but off period is depends on the duration of external trigger pulse. The triple timer IC is not given. For the monostable multivibrator, T1 is equal to 0.6932 R1 C1. For T2, calculation external trigger pulse duration is needed. For bistable multivibrator, both external trigger pulse is required. So generally we know that total time period T is equal to Tn plus T of frequency is equal to inverse of time period, F is equal to 1 by T. So here we may write T is equal to T1 plus T2, F is equal to 1 by T. Okay. Now use this formula, try to solve these questions. If you feel that I can remember this formula, so I can solve this problem. So no need to working operations of astable, monostable and bistable multivibrators. If you need the operation of astable, monostable and bistable multivibrator, and also we need the derivations, the justifications, formal justification, just listen this video fully. First we will discuss the operation, then we will derive these formulas. But if you can remember this formula, no need to understand these concepts and derivation. Operation. First we will discuss the astable operations. This is a circuit diagram of astable multivibrators. Here two RC coupled transistors. When the VCC supply is connected with the circuits, the transistor Q1 and Q2 will try to turn on. The current will flow through the low resistance path by charging the capacitor. The current will flow from here and also current will flow from this path. Because R3 value is very less than R1, so it choose this path. And also R4 is very less than R2, so choose this path. So let me take this voltage is V01, this voltage across the capacitor is Vc1, the current flow from R3 to C1, so the potential is plus minus. The capacitor potential is very much important. So output V02 is this output V02 and the voltage across the capacitor is Vc2. The current flow from R4 to C2, so let us take this potential as plus minus Vc2. Let us take the transistor based emitter voltage is VBE2 and this one is VBE1. Apply Kirchhoff's voltage law for this loop. We will get Vc1 plus to minus, so plus Vc1 plus to minus plus VBE2 minus 2 plus, so minus V01 is equal to 0. Similarly for the KVL for this loop, this voltage is V02, this is Vc2 plus to minus, so plus Vc2 plus VBE1 minus V02 is equal to 0. Due to the mismatch of the transistor, one of the transistor turn on faster than another. So let us assume that the transistor Q1 is turn on first, but we cannot judge which one of the transistor turn on first. So we will assume that Q1 will turn on first. If Q1 is turn on, it will act as short circuits. So what will be the voltage across this voltage? This V1 is directly connected with the ground, so V01 will equal to 0 volt. If V01 is equal to 0, substitute here, we will get VBE2 is equal to minus Vc1. It's negative voltage. So negative voltage means the transistor quickly goes to turn off. The Q2 transistor will become turn off immediately. When the transistor Q1 is on, the transistor Q2 goes to turn off immediately. If Q2 becomes turn off, it will act as open. So what will be the voltage across this point? This point will be maximum VCC. The voltage across this point will be VCC. V02 will become VCC. Now this capacitor is charging in the reverse direction, in this direction, because this transistor is turn on. This potential is zero potential. This potential is zero potential. So the current will flow from high potential to low potential. So the capacitor will charge from this path. So the capacitor charging in the reverse direction. Here this plus minus. When the voltage of the capacitor VC1 reaches the minus 0.1 voltage, 0.1 voltage in the negative direction, the Q2 will become turn on because VB2 goes to higher than 0.1. If Q2 becomes on, it will act as short circuit. If it is act as short circuit, what will be the voltage? Voltage will become 0, directly connected with the ground. If it is 0, immediately the transistor Q1 goes to turn off because VB1 will becomes less than negative value. So Q1 will act as open, V0 will become VCC. So the capacitor VC2 charging in the reverse direction like this, because this point is 0 volt. Always current flow from high potential low potential, so the charging path is this path. When the voltage against the capacitor VC2 reaches minus 0.1 voltage, the transistor Q1 will goes to turn on. Immediately the transistor Q2 will become turn off. This process repeats. Output is taken at the V01 and V02. Output changes 0 to VCC and VCC to 0, continuously changes based on the capacitor charging. When the transistor Q1 is on, the Q2 will become off. When the Q1 is off, Q2 will become on. The V02 will be the complement of V01. We can get the square wave in the V01 as well as the V02. Now we will discuss the derivations. Initially we know that VC1 plus VB2 minus V01 is equal to 0 by the operations. Just before the transistor is turn on, transistor Q1 just before the turn on, the voltage V01 will be VCC because it will be turn off. So V01 will be a VCC. Substitute here, we will get VC1 is equal to VCC minus VB2. VB2 means the second transistor, Q2 transistor. At the time transistor Q2 will be turn on, so VB2 will be 0.7. So we write at t is equal to 0, voltage against the capacitor is VC1 is equal to VCC minus 0.7. At t is equal to tan condition, the voltage across the capacitor is charging in the reverse direction. It reaches the minus points on voltage. So at t is equal to t1 time, Vc1 is equal to minus 0.7 because capacitor charging in the reverse direction. If the capacitor is charging, continuously charging at t is equal to infinite, it will become minus Vcc. This is another condition. We know the voltage across the capacitor equation. Vc is equal to a plus b e power minus t by tau. Substitute this condition, we can find the a and b values. Substitute first condition, at t is equal to 0 time, what will be the voltage across the capacitor is Vcc minus 0.7. Substitute here. So Vcc minus 0.7 is equal to a plus b, because at t is equal to 0, we will get this value. Now substitute the second condition, at t is equal to t1, voltage across the capacitor is minus 0.7. Substitute, we will get the second equation. So minus 0.7 is equal to a plus b e power minus t1 by tau. Substitute third condition in this equation. What will be the e power minus infinity? E power minus infinity is equal to 0. So we will get minus Vcc is equal to a. Now simplify this equation, we can get the value of a and b and tau t1. Substitute this equation 3 in equation 1. We will get b value. B is equal to 2 Vcc minus 0.7. Substitute this equation 3 and 4 in equation 2. So we will get like this. Now simplify this equation. We will get e power minus t1 by tau is equal to Vcc minus 0.7 by 2 Vcc minus 0.7. We know that Vcc is very much higher than 0.7. So Vcc minus 0.7 approximately equal to Vcc. 2 Vcc minus 0.7 very close to 2 Vcc. So substitute this equation, we will get e power minus t1 by tau is equal to 1 by 2. Take logarithmic on both sides, so we will get e will be cancelled, so we will get t1 value. So minus t1 by tau is equal to logarithmic of 1 by 2. So logarithm of 1 by 2 is equal to minus 0.6932. So substitute here, we will get t1 is equal to 0.6931 r1 into c1. Tau is equal to r1 into c1 because the capacitor charging through this path r1 and c1. Similarly for the capacitor c2. So T2 is equal to 0.6932 into R2 into C2 because capacitor charging through R2 and C2. So total time period T is equal to T1 plus T2, F is equal to 1 by T. This is the derivation for the Astable multivibrator concepts. Now we will discuss the operation of monostable multivibrators. This is circuit diagram of monostable multivibrators, the same that of Astable multivibrator, but here this Q1 transistor base is connected with the external circuits. External pulse is applied at the base of the transistor Q1. When the circuit is connected with the DC source, the transistor Q2 becomes turn on first. So the Q2 transistor acts as short circuits. So what will be the voltage? P02 will be 0 because directly connected with ground. So the transistor Q1 will become turn off because base to emitter voltage will be 0. So transistor Q1 will act as open. So the voltage V01 will become Vcc. The capacitor does not charge because the potential are same potential at both ends. There is no current flow here. Now the state is in stable state. The capacitor does not charge. The transistor Q1 always in open condition. The transistor Q2 will always in turn on condition until the external trigger pulse is applied. So let us state this potential is Vc1. So apply Kirchhoff's voltage law around this loop. So we will get plus Vc1 plus Vb2 minus V01 is equal to 0. So Vc1 is equal to Vcc minus 0.1 because here V01 is Vcc. The Vb2 transistor Q2 is in on condition. So Vb2 will become a 0.1 voltage. So Vc1 is equal to Vcc minus 0.7. When the external trigger pulse is applied at the base of the transistor Q1, the Q1 transistor goes to turn on condition. So it will act as short circuits. If it is act as short circuit, the voltage, the output voltage of this transistor Q1 will become 0. If it is 0, the Vb2 voltage will become negative voltage substitute here, VC1 will become negative voltage, so the transistor Q2 immediately goes to turn off. So it will act as open circuits. So the output voltage V02 will be VCC. Now the capacitor Q1 is charging in the reverse direction in this path. Because this point voltage is 0 voltage, they always current flow from high potential low potential, so charge through this path. So the time constant will be R1 into C1, this potential plus minus. When the capacitor voltage of the capacitor reaches the 0.7 voltage, the negative direction. So when the VC1 is equal to minus 0.7, PB2 will become higher than 0.7, the transistor will goes to tan on. The transistor Q2 will goes to tan on condition automatically. If Q2 goes to tan on, it will act as short circuits. So V02 will become 0. The process repeats. For one state, we need external triggerables. For other state, automatically changes by the capacitor. The T1 is same that of Astable Multivibrator. So T1 is equal to 0.693 R1 in the C1. For Bistable Multivibrator, this is the circuit diagram of Bistable Multivibrator. Here, to turn on the transistor Q1, we need the external trigger pulse 1. To turn on the transistor Q2, we need the trigger pulse 2. The turn on period both depends on the duration of trigger pulse. The Bistable Multivibrator is used for the 1-bit storage element. Okay. This is the operations. If you have any doubts related with the discussions, just post your doubts. You can get immediately clarifications. Continuously watch our channel. Definitely you can get the good marks in the competitive examinations. Good. Thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.